Assalamu alaikum. Welcome to our Digital Electronics 2 class. Our this week's topics is about power amplifier, and we have learned already different types of power amplifier, the classifications. Today we'll discuss briefly the Class A power amplifier, details of it. Content of this week: series fade Class A amplifier, then the power considerations. It will come with the output powers, and then finally the efficiency, maximum efficiency of Class A amplifier. Series fade Class A amplifier. So from previous week we already know that the power amplifiers have several classifications. We have Class A, Class B, Class A, B, C and D. So in that we in this week we will going to learn the details of Class A. In details, the bias operation, the output powers, the efficiency, how the circuit is working, how the current is flowing. So for that we are taking as a circuit, a fixed bias circuit connection that is given here, this one, as a reference. So we'll discuss all the equations or anything according to this circuit. So we'll derive all the equations according to this circuit, and you can see this circuit, it is used with a power transistor. Here you can see this is a transistor with some biasing circuit. One is RC, so the power supply is VCC from that RC, and current is flowing there, IC current. And another, the base resistor RB, this one, from that the current flowing to the base is IB. So current IC is the collector current and base current IB. The capacitor is given C1, and input power supply or voltage supply, that is VI, this one. So this is the fixed bias circuit, and for that DC bias operation we can derive one equation, that is the current equation IB, that is base current IB is equals to VCC minus 0.7 voltage. You know, the 0.7 voltage is the internal voltage of this transistor, divided by the RB resistor, that's mean the base resistor. So through this we can calculate the current through the base, that is IB current. DC bias operation. So this is the continuation of the previous slide. We already know the current and the circuit was given. So from that here the equation, another equation, that is collector current equation, that is IC. So previous one was the base current and this one is IC, and IC is equals to beta into IB. And for collector emitter voltage, that's mean from collector to emitter, VCE, collector E, emitter. So this voltage is equals to VCC minus IC into Hertz. So these equations we can use for that circuit, fixed bias circuit. Now the for the DC bias operation of that power amplifier circuit, the collector characteristics graph is shown here. You can see that this is the collector characteristics graph, that means IC current graph. So IC versus VCE or VCC or VCEQ. So this is the IC versus VCE. In this graph you can see one is a Q point, on that point Q point, and that point from we can add this point through the line of VCE, and that is VCC, and if we extend the line into the IC current, and that will be VCC by RC. And on Q point another current is ICQ, that's mean y-axis is through IC current, and this Q point current is named as ICQ current, and voltage in x-axis, that is VCEQ at the Q point. and the line is called DC load line. AC operation for the power amplifier. That's when now if we give an input signal for the amplifier, or an AC signal is applied to the amplifier, you see that in the curve, that is the collector characteristics curve. You already seen that. So in this curve, if we apply the input signal as a sine wave, AC signal definitely, that's why it is sine wave. So you get the output current swing and output voltage swing curve. And this input signal is a small input signal, not the bigger one. Another will have the bigger one in the next slide. So this is the smaller one, and this will cause the base current, IB current, to vary above and below the DC bias point, and it will cause the collector current, that's the output collector current, to vary from the DC bias point set, as well as the collector emitter voltage to vary on its DC bias value. And now if we apply input signal, if this is a larger input signal, so it will vary differently. You see that this is the input signal and this one is a larger one, and the output will vary further around the established DC bias point until either it reaches the limiting condition, whatever the current or voltage. So this one is the output voltage swing and this one is the output current swing. So for the current, this limiting condition is either zero current at the low end, or it is equals to VCC by RC at the high end of its swing. And for the collector emitter voltage, that's when VCE, the limit is either 0 volt, or the supply voltage, that is VCC. So it will swing between this 0 to VCC. Power considerations. So the power into an amplifier, that will provide by the supply voltage, that is supply voltage is VCC. If we do not have any input signal, then the current drawn is the collector bias current, and that is ICQ, because this is the collector bias current ICQ. So without any signal, then the power will be only VCC and ICQ. We'll have only the supply voltage, that is VCC, but no input signal others. So on that, the equations, PI input power, it is DC, so it is equals to VCC into ICQ, equals to VI formula. So the output power, if the circuit has the output voltage and current varying around the bias point, and that will provide AC power to the load. So if we give the supply voltage and also the input signal, then the power equation P0 AC, definitely using the RMS signal, because we need to calculate it in RMS value. So P0 PO AC, it will be VCE RMS value, and IC, that is also RMS, in RMS. So you must calculate it in RMS value. So you can write the equation in another way, that P0 AC equals to I squared C into RC, because VCE is equals to IR, that's when IC squared into RC. And finally we can also write another way, that is POAC equals to V squared C RMS divided by RC. So in these three ways we can write the equations. Whenever we need the equations, we can modify as like this one. And then the efficiency. So efficiency of an amplifier represents the amount of AC power delivered from the DC source. So efficiency must be output divided by input. So the percentage of efficiency is equals to PO AC divided by PI DC, because input signal was in DC, multiplication of 100% to get the result in percentage. Maximum efficiency for this type of that's been class A series fed amplifier, the maximum efficiency can be determined using the maximum voltage and current. So the maximum voltage swing is maximum VCE, peak to peak value is equals to VCC, and for current swing it is maximum IC, peak to peak equals to VCC divided by RC. So from that the output, that's been P output, POAC, and that is maximum output, is equals to VCC into VCC by RC by 8. So is equals to V square CC divided by 8 into RC. Now the maximum power input, that is PI, can be calculated using the DC bias current. So that is PI DC equals to VCC and into maximum IC, and is equals to VCC into VCC by RC by 2. So the final equation will be V square CC by 2 RC. So finally the maximum percentage of efficiency, it is equals to maximum output power AC and divided by maximum input power DC into 100%. So if we put the value, the output power and the input power, then we get that is 25%. So previously you know that the maximum efficiency of class A series amplifier was 25%, and in this equation it is proved that there is 25% is possible through the equations. An example is given. Calculate the input power, output power and efficiency of the amplifier circuit in figure for an input voltage that results in a base current of 10 milliampere peak. So a circuit is given, all the values are given, VCC, RC, beta, RB. So from that we need to calculate the input power, output power, and finally the efficiency. And another curve is given, so that is collector current curve, IC versus VCE. So the curve is given with the values. From that we need to determine the parameters. First in this equation we need to determine the Q point. That's when we in the Q point what are the values, that's when IB, IC and VC at the Q point. So according to the equations of previously, at Q point the IB current is IBQ, and that is VCC minus 0.7 delta RB, so that is 19.3 milliampere. Then ICQ is equals to beta into IB, and that is 25 and 19.3 milliampere, and that is approximately 0.48 ampere. Then the VCEQ, and that is VCC minus ICRC, so the result is 10.4. So now from that result we need to determine the operating point or the Q point. See that this is the Q point. Only the collector characteristics will be given, but we need to determine this Q point. It will not given here. So from that equation, these three calculations, we need to determine the Q point, and you see that this value is under IBQ, and IBQ is 19.3 milliampere. So this is the 19.3 milliampere, and VCE, that is this one, and that is 10.4, more than 10, and IC current is 0.48 ampere. So this line is 1000 milliampere, so 0.48 ampere here. So from that point if we add the rest of the line, so this is DC load line, if we obtain that, so VCE equals to VCC, that is 20 volt, from that to connection with that Q point, and finally they connected with IC equals to VCC by RC, that is 1000 milliampere, so equals to 1 ampere. So this is the connected. So in that point the IC peak equals to beta IB, so 10 milliampere peak value into 25, so total 250 milliampere peak. Now we get the P input AC, output AC, PO AC, and that is IC square RMS value and into RC. So the result will be 0.625 watt, and the input power PIDC, VCC into ICQ, so the result is 9.6 watt. So these are the power output, input power and output power, and finally we wanted the power efficiency, amplifier efficiency, that is percent of efficiency is equals to POAC divided by PIDC. So multiply with 100%. So the result is 6.5%, and that is the efficiency of this circuit. The term paper. So you may have already know about the term paper questions. That you need to submit some assignment or term paper, whatever we say. You need to prepare some answers to the questions that has been uploaded as a term paper. You need to submit that of this several questions that I have already given. You will get this term paper questions in the last week, under the last week, that or under this current week. You will get the questions. After getting that, you need to prepare the answers of the questions. These questions are based on the previous week's lecture, so you will get all the answers from the previous week. You can go through the books or reference paper, reference books, or the lectures that I have given so far. So after getting the questions, you need to prepare the answers, and you need to follow some criteria to answer those questions. First, you must know one thing, that only handwritten type answer is allowed. So you cannot write it in computer or in typing. So please only write handwritten PDF type format. It should be uploaded with PDF type, okay, not in any other format like JPG format, picture format, or any other things, or any Word file. So first write it in your notebook, that's mean in your paper. Then take pictures and convert it with PDF type. That is the main things you can do easily. And you can use the CAMI scanner to get the PDF type. So only upload the handwritten PDF type format answer script. In answer script, in first page, you can write your short details, your name, batch, role, and other things. And don't miss the deadline that is given on the e-learning website. So you will get the details of the deadline, submission of deadline on the e-learning website under the current week. In this week you will get the term paper, and you will also see that what is the final time to submit. So please do not cross that line, okay. In between you must submit the answers. Another important thing, while you will upload the file, that's mean the PDF file, that PDF file should consist the name. That's mean you need to rename the file with the following format that is given here. Suppose I need to write the format in batch underscore role. So batch means your batch, and role means your role. So whatever the batch you are from, write the batch name underscore or space your roll number. So for example, your batch is 46D and your roll number is 4321. So you can write your file name as 46D underscore 4321. Then after writing this, you can upload that file into the term paper or final assignment folder. That's all for your task. Okay, so I hope that you understand, and the questions are given. You need to answer all the questions, no other options. So there are total 4 questions, and you have to answer all the 4 questions. Try to write appropriately, not any unnecessary things you don't need to write. You can directly write the answers. It doesn't need that to write the questions also. You can directly write the answers only, okay. Okay, so that's all for this week. So in this week we have the term paper, so please follow that and submit in due time. So that's all for today. Thank you everyone.